Hello, we are Team 5. We will start presentation about Burj Khalifa. Our team member is 이진웅, 신용택, 장민지, 허성원, 최현준, and presenter is 변상국. We will gonna talk about a lot of team members, weekly plan, summary, background, and 3-day cycle. This is a lot of team members. 허성원 and 최현준 take a lot about day 1 research. 리진웅 and 신용택 take a lot about day 2 research. 장민지 take a lot about day 3 research and making PPT. And 변상국 is presenter. In last week, we had shown a foundation, and today we will present about 3-day cycle. Before starting a 3-day cycle, we summarize foundation which is presented in last week. Dubai, where the Burj Khalifa is located, had very weak ground and a risk of contact with groundwater. A more economical and stronger left-hand file foundation were used to solve the weak ground. In addition, many technologies such as trimming method, addition of corrosion inhibitor, and cathode protection system were used to prevent corrosion by groundwater. This foundation became a strong foundation after many times. Why did the 3-day process need this building? Before entering the whole story, Burj Khalifa is 828 meters building. To build Burj Khalifa, they need a lot of manpower and machines. So it was a project that had to be completed in a short period of time. The most important thing in the construction project was time, which is why Samsung C&T was chosen as the construction company. The Petronas Twin Tower, which is located in Malaysia, was uniquely constructed by one Japanese construction company and the other Samsung C&T. Originally, to build one floor, it took 7 days, but Samsung C&T succeeded in covering the length of the construction to 4.5 days. To make this method a success, concrete pumping technology and two crane handling technology were used at first. This is the most important reason to complete the construction that started later, and to prove the highlights part of technology worldwide and take charge of the construction of Burj Khalifa. We will explain the 3D process that is shorter than the Petronas Tower we showed in the example. Various technologies such as above were used to shorten the construction. Day 1, prefabricating steel bars. Day 2, assembling and molding. Day 3, pouring the concrete to construct one floor. We will explain more details after this slide step by step. First, in day 1, a rubber prefabrication technique was used. To apply this technique to Burj Khalifa, we need smooth weight control. Accordingly, high-speed, high-capacity crane called kangaroo crane and hoist were used. First of all, the prefabricating system was applied to the core walls, wing walls, and the nose columns, which are the main structures of Burj Khalifa. The prefabricated steel cage was moved through the crane to their respective work areas. As a result, quality was managed on the ground in advance, and the number of people going up tower was minimized. So, ensure the stability and reduce the construction time. Moreover, whenever possible, the rubber was assembled in double-story modules to speed up the vertical element construction time. Planning workspace distribution and efficient placement of cranes were essential for smooth procurement and distribution of materials. So we moved the materials needed for the construction to each zone through the temporary load. As you can see the left picture, we plan a logistics schema by dividing each work area like stock area and prefabrication area. The 3 high-capacity self-climbing tower cranes were placed in an appropriate position to provide access to any location, which helped to efficiently handle weight. Since it was a crane in a high-rise building, it was necessary to climb the crane as building was constructed. I will tell you the contents while watching the video in next slide. Let's see this video. Once, they have prefabricated 3 floors The bottom of the crane released the slip up 3 screws and locked back into place. And then the whole crane jumped itself to the next level. People call it the kangaroo crane in its appearance. It was also used to make twin towers. Next, hoist was used. Hoist is a temporary elevator that can be seen at the construction site of a skyscraper. Two types of hoist made by PEGA company from Czechia, large static hoist and jump hoist, were installed in order to efficiently transport workers and cargo. Let me see more details. Large static hoist mainly acts as a transportation of workers and cargo to each work area. The other jump hoist was installed to support the large static hoist. Therefore, the jump hoist stretches as the building gets higher. From this slide, I will present day 2 process. The techniques used in day 2 process include Doka self-climbing formwork, the installation of steel frames, and MEP. First, let's look at the formwork system. High formwork platforms like HYU2020 for heavy load. It endures heavy weight. It has flexibility and cost effectiveness as well as faster circulation speeds. Construction kit can be used for a wide spectrum of use. Flexible cycling can obtain highly cost efficiency. The SKE is flexibly adapted to the structure, angle, and designed for climbing a large number of units in the same time. In this video, you can see how SKE works. Release the rail arms and the rail climbs step by step. And locked in next climb anchor. Formwork climbs step by step. Fix the bearing pin and lock the formwork. Position the formwork. This slide is protection screen X-Climb 6T. This reduces the effect from the weather and ensures safety at high altitude during floor slab formation. It also has a self-climbing system which is fast and safely positioning formwork element. This video shows that the operation of protection screen X-Climb 6T is similar to that of SKE100. Protection climbs step by step. And fix the bearing pin and lock the protection. Next, we will learn about the types of protection. First, polycarbonate inlay. It is translucent, wind impermeable, non-see-through, and provides natural lightening of enclosed area. And by not wind entering, it can provide stability. Second, trapezoidal metal sheet. It is wind impermeable, non-see-through. The protection screen can be dimensioned very flexibly. All gaps are closed off to prevent any tools or other small item being dropped, which increases the standard of safety further. Next, let's look at second construction of day 2 process, installation and MEP. This is a process that takes place after the mold is installed and before pouring concrete. So let's see the installation process first. In installation process, steel cages and composite link beams were used. Before pouring concrete into the formwork, lift the steel cages from day 1 with a tower crane and insert it between the formworks. The link beams were used as means of transporting and equalizing the gravity loads between the vertical members. Because the link members are subjected to large shears and bending moments, many of the link beams were composite members. In this video, you can see the installation of a steel cage. Steel workers assemble steel cages and will become the backbone for the floors and walls of Burj Khalifa. The kangaroo cranes hoist the steel cage up and install that into formwork. In goes the concrete, and 12 hours later, when the concrete hardens, the formwork gets ready for the jump. Next, we will learn about the MEP system used in Burj Khalifa. M is mechanical, E is electrical, P is plumbing service of Burj Khalifa. The MEP system was developed in design stage with the cooperation of designers, structural engineers, and other consultants. Also, the MEP system was installed at about 30-floor intervals. Delivery of the plan to upper levels of the building is carried out by hoist and lift. MEP systems are located at intervals of 30 floors, this typically covering the 15 floors above and the 15 floors below. A central building management system BMS oversees the MEP system operations throughout the tower. All MEP systems were connected to the BMS, which is used to control and monitor all service distributed all around the building. On day 3, the process of pouring concrete. This technology is a very important factor in the progress of the project because it is the most effective in reducing the construction period. We need this technology to pump concrete up to high heights, and it was also very important to mix it with easy to carry. The Burj Khalifa could be constructed in a short period of time with one floor with a 3-day cycle. We will present more details of day 3 and construction next week, including the concrete pumping system used on a 3rd day, conditions taken into account when mixing concrete test, and curtain walls. This slide is our last page. Thank you for listening.